Welcome to our tutorial. I'll go over important electrical concepts in an easy-to-understand manner. This time, I'll talk about ripple noise, which is a very important spec when choosing a switching DC power supply. Let's get started. Let's say you want to buy a new smartphone. What should you check? Well, for starters, it's memory, CPU, and battery capacity. Then you choose the one that suits your needs. Similarly, DC power supplies have basic specifications that you must check before making a purchase. For example, the maximum output voltage, line regulation, and load regulation. One of the key specifications to be aware of is the ripple noise. Ripple noise is defined as a component of minute vibration and noise that appears in the output of a DC power supply. Let's check the waveform for the sake of clarity. When you look at the waveform on an oscilloscope, it appears as smooth, clean, direct current at first glance. However, if you zoom in on the red circle, you can see that there are AC components and pulse components like this. Ripple is a 50 to 60 Hz frequency component of an AC power supply, and a component synchronized with the switching frequency. On the other hand, noise is the fluctuation generated by the power supply switching with frequency components of several tens of kilohertz or higher. These two are combined and expressed as ripple noise. So where does the ripple noise come from? The answer is that the power supply is in the process of producing direct current. This produces the ripple noise. This is an example of a switching regulated DC power supply. The commercial line AC is rectified, smoothed, and converted to DC. The DC voltage is then turned on and off at high speed with a switch, and the pulse width is transformed to AC while the transformer raises and lowers the voltage to the required level. After that, it is rectified and smoothed again to generate DC voltage. In other words, AC is converted and DC output is taken out. In the process of converting this AC to DC, the AC components that couldn't be removed and the noise generated during the switching are added to the DC output in the form of a ripple noise. What kind of trouble will occur if the ripple noise gets bigger and bigger? For digital circuits, the noise level will exceed the threshold level, causing a malfunction. For analog circuits, noise can lead to malfunctions such as unstable voltage signal levels in the circuit due to noise. Because of that, the smaller the ripple noise, the better. However, you can select a regulated power supply that is reasonably priced if the above problems do not occur. Some circuits are not as sensitive to larger ripple noise and don't require such strict specifications. So, it's always better to check in advance exactly what you need. That's it for today. I hope this tutorial has been helpful. We want to share our knowledge and hope it can contribute to your understanding for the future. See you next time.